Hello viewers, I hope all of you are fine. Today I want to verify this wave equation number 1, which is a one-dimensional wave equation, and this is the solution of this wave equation. Now in order to verify this equation number 1, we have to differentiate this equation y is equal to a cos kx minus omega t with respect to x as well as with respect to t. So let first differentiate this equation with respect to x. So by differentiating this equation, it becomes partial y by partial x is equal to a, and derivative of cos kx minus omega t is minus sin kx omega t, where the derivative of inner function kx minus omega t becomes k. So this is the first order derivative. Now by differentiating again this equation, it becomes partial square y by partial x square, and this side becomes derivative of sine becomes cos kx minus omega t, and again the derivative of this inner function becomes k. So k multiplied by k becomes k square a cos kx minus omega t. Now as we know that a cos kx minus omega t is equal to y, so that's why we can replace a cos kx minus omega t in this equation by y, so it becomes equation 2. Now let again differentiate equation star with respect to t, because in equation 1 t is also involved. So by differentiating y with respect to t, it becomes minus a sine kx minus omega t, and derivative of kx minus omega t with respect to t becomes minus omega. So minus minus becomes plus, it becomes a omega sine kx minus omega t. Now by again differentiating with respect to t, it becomes partial square y by partial t square is equal to a omega, and derivative of sine is equal to cos kx minus omega t, and derivative of this inner function with respect to t becomes minus omega. So it becomes minus omega square a cos kx minus omega t, and we know that a cos kx minus omega t is equal to y. So it becomes minus omega square y. This is equation number third. Now equation 2 is partial square y by partial x square, and equation 3 is partial square y by partial t square. Putting the values of partial square y by partial x square and partial square y by partial t square from equation 2 and from equation third in equation number 1. So after putting values in equation 1 becomes like this. This is the equation number 1. Minus cancel with minus, y cancel with y, it becomes k square is equal to 1 over v square omega square. Now we know that k is equal to 2 pi by lambda, and omega is equal to 2 pi f. So by putting values of k and omega in this equation, it becomes 2 pi by lambda is equal to 1 over v square and 2 pi f whole square. So 2 pi cancel with 2 pi, even if we apply square, it becomes 4 pi square, and here on this side it also becomes 4 pi square. So 4 pi square cancel with 4 pi square, here I directly cancel it, and in bracket we have 1 over lambda square, and here we f square. So it becomes like this: 1 over lambda square is equal to f square by v square. But we know that v is equal to f lambda. So by putting value of f, f becomes v by lambda. So it becomes v square by lambda square. So v square becomes cancel, and on this side we have also 1 over lambda square. So left hand side equal to right hand side, which proves that basically y is equal to a cos kx minus omega t is the solution of this wave equation, and hence this is a particular wave equation in one dimension, which is our purpose of verification. So I hope you like this video. We verify this equation here. For further interesting and amazing videos and for exploration of nature, subscribe this channel. Thanks for your time and patience. Thanks once again.